on HackerRank problems, and in this we'll be dealing with the
Welcome to
algorithmic intermediate problem solving problem, extra long factorials. So basically, before we start this problem, what we need to understand are what are factorials, right? So given a value n factorial, right, as you can see on the second, so given a value n factorial, right, as you can see on the screen below, this basically translates to n into n minus 1 dot 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 dot. So until we reach 1, right? That is basically what a factorial is, basically, right? Considering that, potentially, if we get a very huge value, like let's suppose 25, right? That poses a challenge for a computer because there is something called overflow, right? So if we do 25 into 4 into dot 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 1, right? So we have this value over here, right? Potentially. This factorial is very low. What it would cause potentially in a computer is an overflow. Values become too large, integer values become too large. It creates a problem called overflow, in which it starts creating inaccuracies in your digits because it doesn't have the memory or capacity to deal with the additional amount of integers within your answer, basically. So this overflow becomes a problem at that point. So potentially, if given an extra long factorial, we need to calculate a code that could actually quite simply solve this answer. I mean, the best way to solve this answer is to just use the math dot factorial method from the math library, right? But and we're going to use that right now. We're going to show you how to use that because this function has been already been prepared to deal with extra large factorial, and this is something that you'll do in actual life when you're programming, right? But the issue with that is you're doing a coding interview. Nobody's here to just see your knowledge about just using writing one line of code and solving the problem using an already defined method. You need to solve this question ultimately on your own. Potentially, you can, this practically purposes, or just at the end, you can let them know that you can use this method as well. So we're going to write this code ourselves. So first, let's just go over quickly over the factorial, answer and how you can use the math.factorial version to get this done. So simply speaking, given a value here, we call that result, right? We create a variable called result, and within that variable called result, we use the math.factorial, uh, function, and just add the value n that we're getting here, and then we need to n, and then we need to close. Then we need to simply print this out to the console because that's what ultimately we need to do. So let's get this answer here, run this code, and you'll see it would work potentially. But this is not the answer that people are looking for. It solves both test cases, right? But the issue here is, again, this solves the problem, but nobody's there here to, encode it and encoding it. You just use a simple uh, uh, math.factorial function and you're done. That's not the case. You need to solve this problem in that question. And to do that, you need to basically do the factorial calculations on your own. So to start everything off, we can use result. We can equate result equals to 1 because factorial of 0 would always be 1. So if we get a result of 1, we always send the value 1 out there. So as a default value, we get a variable called result with a value 1 because factorial of 0 is 1, and if we get a value of 0 or anything else, we need to default the value to 0. Then we need to loop over from 1 to n digits, the amount of n digits, and multiplying the result of each number by the next, basically. For that, we're going to run a for loop. So we're going to say for I in range, basically, that I in range, we need to start at 1 and end at n plus 1. basically. So that is, and with it, it's just one line we do, right, where we multiply using syntax sugar the value of whatever I is into the result. So result star equals to n, I in this case, right? So any value of I is multiplied to the existing value of result, and that new value is equal to the new value. So with that out of the way, the last thing we need to do is again print the result. So that's how you basically write a factorial problem. So yes, we just write print and result. So let's run this code. That should solve our problem as well. So relatively speaking, this problem was simple enough. The issue here was the long factorials. To solve that problem explicitly, you can use the math.factorial function. But if you want to potentially, or if you're in a coding interview, if you want to use this method to show step by step exactly how you solve the factorial problem. With that, we're going to wrap this video up. If you got any value from this video, please like and subscribe, and let us know in the comments if there are any issues you want us to address. And with that, we're going to wrap this video up, and we'll see you on our next video. Thank you.